Hi, my name is Gary Schnell, and I would like to invite you into my home again to explore the 6th chapter of my recently published book, Consciousness, All in One and One in All. In these next few chapters, we are going to attempt to look at the problems that exist for the theory of quantum physics and the nature of the observer, which seems to be the source of many of these problems. In this chapter, I'm going to briefly discuss different quantum interpretations and how those interpretations relate to the problem with consciousness. Now, the nature of observing and knowing information has been debated for centuries. In the 1700s, Rene Descartes split things up a little bit for us and started talking about what's been labeled Cartesian Duality. And what this means is that there is a difference between mind and matter in kind. And I'm going to take matter to include the brain as separate from mind as we go along here. The brain, after all, is physical. It involves electrochemical changes to process and transport information. Now, the problems with quantum physics involve different things, like you may recall what I said about entanglement and how if we have two particles that are intimately that share information on an intimate level, and they go off into 180-degree different directions, and we measure one here and the other one is over here, such that this one that we're measuring is in a redshifted universe and this one is in our universe. If this one is measured, we know everything we need to know about this one without any measurement, and we know it instantaneously. Well, that bothered Albert Einstein, who insisted on something called hidden variables, because he couldn't come to grips with this idea of spooky action at a distance. So the hidden variables theory of quantum physics involves the idea that there are variables to each collapsed particle that we just can't understand and can't fathom. This idea of hidden variables was squashed mathematically in the 1960s by a fellow named Bell, who developed something called the Bell inequality theorem. This was later This inequality theorem was later proven in the 80s by a fellow named Alain Aspect, such that we know that there are no hidden variables. Another interpretation of quantum physics is the Copenhagen Interpretation. This involves an observer, and with each observation, there is a corresponding experience, so that with each choice we have one experience. There are a number of problems with this that were addressed by the Schrödinger cat paradigm, whereby the cat is in a box with a deteriorating atom, and once the atom deteriorates to a certain point, poison is released and the cat dies. But according to those who criticize the Copenhagen Interpretation, we can't know that the cat died until we open the box. So really, according to this interpretation, the cat doesn't really die until it's observed. Now, this was wasn't meant to be a serious situation. It was meant to display the problems with the Copenhagen Interpretation. And then there's another group of interpretations, because this involves a couple of different things. There are certain theoreticians who refer to themselves as physicalists. Now, physicalists assert that the mind is an epiphenomenon, or is derived from the brain, such that the mind is a byproduct of physical factors. Now, the problem with this is that it denies our experiences on a day-to-day basis. It denies the idea that we have free will. And these are things that we experience routinely, but are denied. So the physicalists have essentially attempted to do away with consciousness altogether, and asserted the meaningfulness of Schrodinger's equation, such that each experience, rather than being a conscious choice, each experience splits off into a different world, such that essentially the world is the universe is a superposition, and a superposition with each choice, we reduce, we collapse that superposition, and it goes off in one direction, while the universe that we live in is the superposition that comes off in our direction. The problem with this is that for the most part, these physicalists are very much scientifically oriented, and this idea, among other issues, which we'll talk about later, this idea involves, it can't be proven scientifically. This split can't know about this split. So we see that there are a number of problems with how we understand quantum physics, though experimentally, it's the most validated theory we have. Now, what I'm going to start talking about here is a topic that I refer to as information interdependence, from the standpoint of our brain, mind, consciousness. This is information that is derived from a couple of psychologists, one named Ron, and he spells it somewhat differently. It's R-H-A-W-N, Joseph, J-O-S-E-P-H, and Michael Gazzaniga, G-A-Z-A-N-I-G-A. I hope I'm not butchering his name too much. And basically what these two men find as they study the brain is that the brain is functionally organized, and seemingly this organization is localized to different areas. However, to be clear, this is very superficial, because the brain is made up of billions of neurons, and there are trillions of interconnections between these neurons, such that there's no isolated locality. Everything in the brain is informing everything else. There's an interdependence of information. One of the ways this is exemplified is by this a notion that is referred to as blind sight, such that if we wipe out the occipital cortex in the back, where we process visual information, we can still see. The rest of our brain is still operating enough that we can make out shapes, and we can make out movements such that if we were a frog, we'd be able to perhaps flick our tongue at a passing by fly, so that there is a processing of visual information even without the occipital cortex. It's referred to as blind sight. Another phenomenon that they observed was something called a split brain phenomenon. And what this involves is we have two sides to our brain, a right and a left. They each process information in their own idiosyncratic way, and they each tend to have a preference for the information they process. I don't want to get into the specifics of this, but there used to be a way of treating what are called intractable seizures that they just can't come to grips with from a treatment standpoint, and that way involved cutting the connections between the right and the left brain. Now, the corpus callosum is where those connections are. It's the part of the brain that connects the two. So they're cutting the corpus callosum in an operation called a callosomotomy, such that the left brain and the right brain really are having a difficult time communicating. So, and again, I don't want to get into specifics of this, but if the word toothbrush is presented to different visual fields, what will end up happening is that both visual fields, we have evidence that both visual fields will see both words, tooth and brush. And with one of the fields that has to do with our language center on the left side, we can say the word tooth, while we have a difficult time, we can't say the word brush, and in fact we'll deny that we even saw it, even though when we're asked to point, we can point to tooth and brush with our hands. So that information is there, it's just not available to the left language center. They also observed a number of interesting phenomena that can be a little bit cute and funny when they looked at these folks that had these operations, like a person going into a store and picking up cigarettes with one hand, only to have the other hand object and put them back without this hand knowing. Or some fella perhaps hitting somebody with one hand, only to profusely apologize when realizing what had happened. So those are just a couple of the phenomena that they discussed, but there are other examples. Another phenomenon is what we call disconnected consciousness, and this we commonly know as a tip of the tongue phenomenon. There's a couple of areas in our temporal lobe, a Wernicke's area where we comprehend language, and a Brokaw's area where we express language, and these areas can be disconnected, and for me as an older guy, they're disconnected all the time. I know a word, but I can't think of it. It doesn't mean that I don't know it. It just means that I can't think of it. There's another phenomenon called denial of blindness, whereby, again, if you wipe out that occipital cortex that I was talking about, the rest of the brain does not know that that area has been wiped out, and will insist that the person who's had that unfortunate thing happen to them is not blind. When I close my eyes, the rest of my brain is aware that I'm closing my eyes, and that's the reason that I'm unable to see. But if I wipe out that area of the brain, the rest of my brain just isn't aware of it. And this is somewhat similar to what happens when we have damage to couple of areas on either side of our brain called the parietal areas, whereby, and these areas are responsible for movement and sensation, so that if there's some kind of a cerebral accident whereby we lose a certain part of our parietal lobe that has to do with the right hand, for example, my right hand is still there and I can see it, but my parietal lobe in my brain has been damaged, and I will deny that this is my right hand, somewhat like the denial of blindness. The thing that we're more commonly aware of because of wars, Civil War, for example, is when our parietal lobe is intact, but we've had an amputation. And what will end up happening is we will have a sense that that limb is still present, and we may even deny that we've lost that limb. So what I'm trying to say here is these areas are not localized. They all have different parts of information that they all share with each other, and they're there, but sometimes we're not aware that they're there. We're not consciously aware that they're there. So I want to move to something I'm going to call a continuity of consciousness for the time being. Like, if I sit down and read this book for an hour, I make a decision to read the book for an hour. Now, does that mean that I've made one decision to read this book, and the next hour I'm not making any decisions at all? Of course not. My body is processing information continuously. Whether there's a smell of a fire, chocolate chip cookies baking in the kitchen, or a dog barking outside, or information that I'm cold or uncomfortable, or that I have to go to the bathroom. All of that information is being processed continuously, and I am continuously making a decision, a choice, though it may not be conscious and it may not be informed until it reaches a certain level of stimulation, like finally the detrusor muscle of my bladder informs me that I really better go to the bathroom, or there's going to be a problem. At that point, it reaches my consciousness and I make a decision to do something about it. Well, up until that time, I have decided on an unconscious level to not go to the bathroom. I don't have to go to the bathroom. And the same thing for something, maybe this can be better exemplified by the idea of driving a car. Now, when we drive a car, we make decisions continuously, but we're unaware of these decisions, even though oftentimes they're life and death decisions. We can go from point A to point B without really remembering how we got there. And during that time, we don't go through red lights. We don't hit people that are crossing the street. So we're making a number of life and death decisions. But if we buy a new car and we're driving down the road, all of a sudden we are aware of all the other astute and intelligent people that have bought the same car. It's not nearly as significant as not getting into an accident or not hitting somebody, but all of these people are just as smart as we are, and they have bought the same car. So what I'm trying to express here is that consciousness is a continuity of prior knowledge, prior experience, beliefs, expectations, situations that we're in at the present time, and that our decision to attend to the stimulation with which we are presented is informed on multiple levels, multiple areas of our brain that are all interdependent with one another. For example, some of the things that we're informed by are unconscious or implicit. I had a friend. He recently died, and but he'd been married, and he wrote about this. His name is Dr. Todd Davidson. He's a a noted psychoanalyst in the Milwaukee area. When he was married, before he died, his wife had this ritual of making all the beds, changing all the linens before dinner parties. So one day he came home and she asked him to help, and he wondered why they were changing the linens for a dinner party. And she couldn't tell him. She didn't know why. But she said, "Oh, my mom always did it." Well, so they called Mom. Mom said, "Yeah, I'd always done that. I would change the linens before every dinner party." Well, Mom didn't know why she did it either, except that Grandma had done it. So they called Grandma. Now, Grandma could give a reason as to why she did it, because she had a dinner party, and the bridge for the road had been washed out by a storm during the course of the dinner party, so that everybody had to stay overnight in her home. And she was embarrassed by the fact that people were sleeping on dirty linens. So her angst and worry was communicated to her daughter without context, but without the context of Grandma's context, but within the context of Grandma's angst. And this angst was communicated to her daughter, Todd's wife, in much the similar way, without the previous context. Neither of them could tell you why, but they did it. Now, our conscious decisions to attend to different things can also be informed by experience. And I'm going to use the example of PTSD here, whereby we can freely go to enjoy 4th of July fireworks, not give it a second thought, not feel that we're in danger. But that's because we're experiencing these explosions, if you will, in a non-harmful environment. Now, someone who's been in the military and gone to war has experiences of these explosions in a hostile environment. And what can happen is that when these explosions occur in a hostile environment, the fight or flight response, fight, flight, or freeze response, can be so activated that it overwhelms the part of the brain, the hippocampus, the part of the brain that's responsible for putting these things into a context, so that we lose the ability in these situations to put explosions into a context in a general way, so that we experience any explosion, we lack context, and we act as if we're back in the war. And this is what's called PTSD. Now, there's also, the idea of how prior knowledge can inform our ability to attend. I was at Tenaya Lake, which is in Yosemite, with my wife back in 1981, and what a place to be if it's a full moon on a clear night up in the mountains, and to be on that lake. It's the neatest color of blue all around you, different hues of blue. So the information that we're presented with at the time is, boy, this is beautiful, and we're enjoying each other's company until someone across the lake yells that he's seen a werewolf. Now, that's only important because we all know that werewolves only live in California. And I say that tongue in cheek, of course, but what's interesting is that then that knowledge of the werewolf, in this example, kicks in, and it overrides our knowledge of each other, and the quiet night, the beautiful blues, and we take off because we're now informed by something other than the moon and the beauty and each other's company. The final example I'll leave you with is the placebo effect. Now, the placebo effect is an example of how expectations can inform our attention. Now, we give someone a sugar pill and we tell them that it's meaningful, and at least 35-40% of those people will respond as if it is meaningful. And if the person who's communicating that is really an empathetic, believable person, those numbers will rise even higher. This gets into a whole line of study that's now being done. We can perform surgeries that have a placebo effect. We can induce a blister formation by telling someone that there's a lit match by their hand, even when there isn't one, while under hypnosis. These are things that are dependent on expectations. So we've got this idea that everything is informed on some level, and that information is there, but we may not be privy to it. And we've got the idea that it's informed in a number of different ways. But now I'm going to ask you to think about how a single cell is involved in all of this, because our brains are made up of billions of cells with trillions of connections via things called dendrites. And these connections they can either cause a subsequent brain cell to become depolarized and transmit a signal, or they can inhibit the depolarization and keep that nerve cell from transmitting information. And the fact of the matter is that there are any number of dendrites that are impacting on any nerve cell, such that the potential for depolarization or inhibition of depolarization is very nuanced. And what's significant about this is that this single cell, and all the cells in our body work the same way. We all process information from our environment via electrochemical signaling. And this electrochemical signaling depends on a number of processes that go on in each cell that have to do with the transcription and translation of DNA into RNA, into the collection of amino acids. It's something called the Golgi process, which are then packaged into peptides and eventually into proteins, which are then packaged and released outside the cell membrane. All the while, all of this stuff requires energy that we're deriving from a certain other part of the cell called the mitochondria that can involve things like we call electron transport or oxidative phosphorylation or the Krebs cycle. And believe me, in medical school we had to learn the Krebs cycle, and it's not a fun thing to learn. There's like 36 ways that electrons can be used to provide energy. But all of these things are going on in each cell as we process this information, informing the next cell and the next cell. And also to be considered in all of this is the cell membrane, which is just as complex, and it protects the integrity of the inner part of the cell, and it allows for transport of things into and out of the cell by processes called osmosis and diffusion, which are passive processes. And then there's active processes that include transmembrane protein channels. And these transmembrane protein channels, they are quite complex. There are more than 300 of them. And if you were to denature the cell wall and string these ion channels out and ask them to reconfigure, it could take hundreds of years because of the intricacies involved. Now, because there are catalysts and there are ways that these things bend, it doesn't take more than a minute and a half for these cell membranes or these transmembrane protein channels to reconstruct themselves. but there's any number of ways that they have to follow. So all of this in the name of processing outside information that is then electrochemically communicated to other cells in the brain with these involved neurotransmitters, so that the information that we're getting in, this is what we call bottom-up information. It has to get into our brain from outside. Whereas the things I was talking about before, the knowledge, the experience, expectations, the situations, the beliefs, that is top-down information, so that there is a meeting of this bottom-up information with this top-down information, and it's based on that meeting that I decide whether I have to go to the bathroom, or I decide when this video is over. And this video is over at this point. It's been a long one, and I apologize for that, but the things I'm talking about are somewhat complex. I hope you've enjoyed it. I thank you for staying with me. I hope you've learned something, and I look forward to seeing you for my next video. Take care and be well.